Today, everyone is talking about co-packaged optics, CPO, and some people think it could completely change AI infrastructure. And honestly, they might be right. Because as AI data centers scale, the amount of data moving between the GPUs is becoming absolutely insane. But here's the problem nobody's talking about. AI infrastructure is exploding right now, not 5 years from now, but today. And companies like NVIDIA, Microsoft, Amazon, Meta, and Google cannot wait for perfect future technology before scaling AI. They need solutions immediately, which means before CPO fully arrives, there's an entire layer of companies quietly winning first. And honestly, some of these companies may become the biggest AI infrastructure winners of the next several years. So in this video, we're gonna break down what CPO actually is, why everybody is suddenly talking about it, why it may still be early, and the companies that could win before CPO fully arrives. So first, what exactly is CPO? Co-packaged optics. And the easiest way to understand this is to understand the problem the industry is trying to solve. Right now, AI data centers have enormous amounts of data between the GPUs. And when I say enormous, I mean absolutely massive. As AI models get larger, GPU communication becomes one of the biggest bottlenecks of the entire system. Today, the architecture usually looks something like this. You have the GPU to the transceiver, to the fiber optics, to the switch, and then back to the fiber optics, and then to another GPU. And this works, but as AI clusters scale, the amount of power, heat, and complexity starts becoming a huge problem. Because traditional electrical connections begin running into physical limitations. You need more power. You need more heat. More latency, more signal loss. And that's why the industry is becoming obsessed with optics, because light can move data far more efficiently than copper. This is why networking speeds are rapidly moving from 400G to 800G, and eventually towards 1.6 terabit networking. And the amount of bandwidth needed for AI infrastructure is exploding. And this is where CPO enters the story. The idea behind co-packaged optics is moving optics directly closer to the switch chip itself. Here is a video also explaining CPO.
If you imagine that data is cargo, traditional networking is like trying to ship from an inland factory to a distant port. CPO is like building a waterfront factory with an integrated dock. The cargo travels quickly from origin to destination, saving time, reducing energy use, and avoiding risks. But how exactly does it work? CPO unites silicon and light into one unit. So instead of relying on separate components that must convert electrical signals to light and then back again as data travels, CPO moves optics off of separate pluggable transceivers and places them directly on a silicon wafer right next to the processing chip. By eliminating long, power-hungry electrical lanes between ASICs and optics, CPO dramatically reduces power consumption, minimizes signal loss, and accelerates data speeds.
So the goal is lower power consumption, lower latency, reduced heat, higher rack density, and much more efficient scaling. And some estimates suggest CPO could dramatically reduce power usage compared to traditional architectures. So when investors hear that, they immediately think, okay, this is the future. And honestly, it probably is part of the future. But here's the important part. The AI boom cannot pause while the industry waits for CPO. That's the key idea in this video, because AI infrastructure is scaling immediately And CPO still faces major challenges: manufacturing complexity, thermal management, for serviceability problems and cost, and ecosystem transition risk. Even NVIDIA has discussed that this is a multi-year roadmap, which means before CPO fully scales, there may be an entire transition phase where other infrastructure companies quietly dominate first. And that's where things get interesting. Because before CPO replaces pluggable optics may experience their biggest boom ever. That's the contrarian idea. Right now, AI clusters still rely heavily on optical transceivers. These are the components that convert electrical signals into optical signals using lasers. And every massive AI data center still needs them today. In fact, AI demand is creating a huge wave of growth for 800G transceivers, optical modules, fiber connectivity, and eventually 1.6T networking hardware. The AI build-out is literally creating an entirely new wave of optical infrastructure demand, and there are real-world examples already happening. Corning recently partnered with NVIDIA to help expand their fiber optic production tied to AI infrastructure growth. And that's important because it shows the hyperscalers are now scaling, and they're not waiting. This creates opportunity for companies already deeply positioned inside the optical ecosystem. Companies like AAOI, Applied Optoelectronics, and Coherent, Lumentum, and Fabrinet. These companies are already participating in the current optical networking build-out. And honestly, before CPO replaces transceivers may experience their strongest demand cycle ever. And that's the bridge opportunity. And then when we get into what may become one of the biggest hidden AI bottlenecks of all is lasers. NP lasers, the few companies that make NP lasers, because none of this optical infrastructure works without lasers. Data centers are increasingly moving data using light instead of copper. And that requires lasers, optical engines, indium phosphide, and advanced photonics manufacturing. And this is where things get very interesting, because manufacturing these components at scale is extremely difficult. You have epitaxial growth complexity, yield problems, packaging challenges, and limited production capacity. Some analysts are now starting to argue that optics could become the next major AI bottleneck, not GPUs. Optics. Because GPUs are useless if the data can't move. And that line right there might end up becoming one of the biggest themes in AI infrastructure over the next several years. And this is where companies like Sivers Semiconductors start becoming interesting speculative plays. Because Sivers has exposure to indium phosphide technology and optical laser infrastructure. Now, obviously, Sivers is much smaller, higher risk compared to larger players, but it shows how deep this optical ecosystem goes. And then you have companies like Coherent and Lumentum, which are heavily involved in photonics and optical infrastructure scale. And if AI networking demand keeps exploding, these companies may become benefiting long before CPO fully takes over. Now, another layer most investors aren't talking enough about is the connectivity layer itself, because as networking speeds increase, signal integrity becomes harder and harder, and this is where the DSPs, switches, and the networking chips become critical. And this is where Broadcom and Marvell and Broadcom, the networking chips, have been aggressively expanding its AI networking infrastructure business, with things like Tomahawk switches, AI Ethernet, and ultra high-speed networking solutions, because massive AI clusters require increasingly advanced networking architectures. And Marvell is also deeply involved in AI networking, optical connectivity, and photonics infrastructure. Marvell has made acquisitions and investments tied to optical networking and future photonic architectures. And here's the important thing. Even if CPO becomes the future, Broadcom and Marvell may still dominate critical parts of the ecosystem anyways. And that's what makes this entire transition phase so interesting. Because the companies winning before CPO might also become some of the winners during CPO. Now, to be clear, this does not mean CPO fails. Actually, I think CPO probably becomes extremely important later this decade, because eventually AI scaling may force lower power consumption, higher density, reduced heat, and much faster interconnect architectures. And at some point, the current architecture may simply become too inefficient. And that's why companies across the industry are heavily invested into CPO research and development. But timing matters. And this is where I think the market sometimes gets ahead of itself, because investors often rush towards final future technology while ignoring the companies making money during the transition phase. And sometimes the transition phase is where the biggest investment opportunities actually exist. That's the real thesis here. Before CPO fully scales, AI still needs transceivers, lasers, optical modules, fiber infrastructure, DSPs, networking switches, and massive optical connectivity expansion. And that means there may be a multi-year investment opportunity before CPO fully arrives. And honestly, sometimes the biggest winners aren't the final technology. They're the bridge that gets the industry there. So, that's it for the video. Let me know in the comments, what company do you think wins before CPO fully arrives? And if you're getting value from these videos and want deeper research, early access videos, portfolio updates, and members only posts, I also started a Buy Me a Coffee membership link below. And that support generally helps grow the channel and lets me spend more time researching these hidden infrastructure stories. Thanks for watching, and I'll see you in the next one.